Assalamualaikum warahmatullahi wabarakatuh and good day. So now we continue with example 10.3 for subtopic 6.2, which is type 1 error and type 2 error. So from previous video, okay, you can refer example 10.1 and 10.2. We are talking about John's vote. Okay, so now in example 10.3, we are calculate the value of beta if Jones will receive only 10% of the votes, which is P equal to 0.1. So in previously, example 10.2, we have P equal to 0.3. Okay. So now in this case, we want to calculate beta when P equal with 0.1, which is another particular value of null hypothesis. Alternative hypothesis. Okay. So you know that beta is type 2 error, which is accepting H null when P equal with 0.1. Okay, which is alternative is true. So again, the test statistic is not in rejection region. Okay, when P equal with 0.1, so you still have Y greater than 2 because type 1 error, the rejection region is less than equal with 2. Okay, so when you have this one, you still have Y equal to 3 until 15, but instead of P 0.3, now you have you have P equal with 0.1. Okay, so again here you can calculate, okay, using statistical table. Okay, look, your Y, this one the other way around lah. You can actually do 1 minus P Y less than equal with 2. Okay, this one is easier compared to this one. This one you will have what? Y equal to 3 plus Y equal to 4, Y plus equal to 5 until Y equal to 15. But this is the other way around. You can have 1 minus P Y less than 2. But in this case, in this example, your P is 0.1, not 0.3. Okay. So if you look table, you will get 0.184. Okay. So consequently, if we use Y less than 2 as the rejection region, the value of B when P equal to 0.1 is smaller than the value of beta that we obtained in example 10.2. Okay, because in example 10.2 our P is 0.3, okay, which is different. But now when our P is 0.1, we will have this 0.184 and the other one is 0.873. Okay, very different. So nonetheless, when using this rejection region, okay, we still have a fairly large probability of claim that John is a winner if in fact he will receive only 10% of the voters. That's mean because we calculate type 2 error, or we call beta. Okay, so beta is type 2 error, which is what? We accept H null when HA is true, isn't it? So HA is true, P 0.1. Okay, but then if you look here, our probability is 0.184. Okay, still we consider the John can be a winner. Okay, with 10% of the voters only. Okay, so that's example 10.3. You should understand what is alpha, what is beta. Okay, and then this one the other way around. That's mean the P, the proportion. Okay, this one is 10%. The value of we accept H null when HA is true is 0.184. Okay, but 0.873 ni actually come from this one, isn't it? Okay, which is when P equal to 0.3. Okay, we accept H null when HA is true is 0.873. Okay, so the probability is big compared to this one. Okay, but still, even this one is smaller compared to 0.87. Okay, we still have a fairly large probability of claiming that John is a winner if in fact he only received 10% of the votes. Okay, so you should understand. This is quite tricky, but if you understand, it will be okay. So now we move to example 10.4, page 493. So if you refer to the test discussed in example 10.1, okay, now let's say we consider the rejection region is less than equal with 5. Okay, before this we have 2, isn't it? So calculate the level of alpha if the test and calculate beta if P equal with 0.3. And then compare the result with the values obtained in example 10.1 and 10.2, where we use the rejection region y less than equal to 2. Alright, so now we look when we have y less than equal to 5, and the first one is p equal to 0.5 lah. Okay, so we calculate alpha. So here you can see that you have y from 0 until 5. So when you look table or you calculate, you will get 0.151. Okay, and then now using the p equal to 0.3, so this one is HA. Okay, or we call it theta A. Okay, so in order to find the beta type 2 error, so you have this one. So instead of less than equal, you will have greater than because it's not in the region. And then you substitute the value into the binomial distribution here. Then you will get 0.278. Okay, so if you make comparison, okay, you can see from the table 10.1, more easier lah. Okay, if you look table 10.1, you can see that when our alpha here, okay, when rejection region, so you have two rejection region, y less than equal with 2, y less than equal to 5. So your alpha will give you 0.04, and then here 0.151. This one when your p is 0.5. Okay, so what is alpha? Type 1 error. Reject H null when H null is true. So you can see that when we have rejection region less than 2, the probability to be to get a type 1 error is very small, okay, compared to this one. Okay, but when you have a beta, when p 0.3, okay, this one 0.3, but the rejection region is different, 2 and 5, you can see that type 2 error is what? Accept H null when H null is false. So you can see here it's very big, isn't it? 0.87. And compared to this one is better lah compared to this one. So basically this one and this one is better compared to the other two. Okay, it depends on the situation just now. Alright, so you can see explanation here. Okay, a comparison of the alpha and beta calculated here with the result of example 10.1 and 10.2 show that if we enlarge the rejection region, okay, from y less than 2 to y less than 5, okay, you can see that increase alpha and decrease beta. Increase this one, decrease this one. Okay, so you can see from here, okay, hence we have achieved a better balance between the risk type 1 and type 2 error, okay, but both alpha and beta remain disconcertingly large. Okay, so how can we reduce both alpha and beta? Okay, so the answer is intuitively clear. Shed more light on the true nature of the population by increasing the sample size. Okay, this is what in statistics. Okay, if you want to reduce the value of alpha and beta, which is type 1 error or type 2 error, you need to increase the sample size. Okay, in applied statistics, you can see as well, isn't it? How to reduce the estimation error, the marginal error too. Okay, usually we increase the sample size. So for almost all statistical tests, if alpha is fixed at some acceptably small value, beta decrease as the sample size increase. Okay, so that one also can be used lah. Okay, so I think that's all for type 1 error and type 2 error. You can try do exercise question 10.1 until 10.7. Okay, if you have any difficulty to understand or if you do the question and want to check, you can ask me. Okay, so basically in subtopic 6.2, you calculate how you calculate type 1 error and type 2 error. Okay, sometimes it can be continue from the 6.1 too. If you look 6.1 actually you get the region, then you need to find the alpha or beta. So how to find alpha and beta is using subtopic 6.2. Okay, so I think I stop for 6.2 here. All right, and then we'll continue next video with 6.3. Thank you.